So today I'll cover a topic of subsetting. So subsetting is a way of extracting element from a bigger element. It can be a vector, it can be a data frame, it can be a list. Okay, and there are multiple ways of extracting element from a bigger element, and that is called subsetting basically. So here we have basically three operators. So first is using big bracket, second is using two big bracket. Okay, then we have another operator that is called a dollar symbol, and these are three way of extracting element from a vector or a list or a data frame. So first is this single big bracket. This operator is used to extract element from a vector, and it always returns an object of the same class as of the original. Okay, so that means, for example, if the original class is of a vector, of a numeric vector or a character vector, so the subsetted element must also possesses that same class. That means the subsetted element as well as the original element must have the same class. Okay, I'll show you the example. Then second is using two big bracket. This operator is used to extract element from a list or a data frame. So if you recall how R creates a list, it will basically uses a two big bracket for the compartment, and inside that compartment it basically use a single big bracket for individual placeholder, right? So this is the inherent nomenclature, and we'll just have to use this two big bracket for extracting the element from a list or a data frame. Then the third one, and here the extracted object and the original, right? There the data set data type should not be the same, right? So the class or a data type of subset element and class of original element, these two are different in the case of big bracket, double big bracket. If you're using double big bracket for extracting anything, so in that case the class of original and the subsetted element must be different. Okay, then third one is using this dollar operator. Okay, this operator is generally used to extract element from a list or a data frame, and this operator is generally used whenever we have a name. Okay, so if you have a name, you can use this dollar symbol and you can extract that thing very easily. Okay, so let me just give you here example. So first I'll create a vector, and for creating the vector you can do very easily using the combine operator or concatenate operator. So here the C with parenthesis, this is a combine operator, and here we'll have to specify bunch of number. So right now here I'm just specifying bunch of numbers. So this is a numeric vector I'm creating here, and I'm storing this whole thing in X. Okay, so let me do that. Okay, so let me just first clean all the stuff because there are a whole lot of other things from the previous session. So I'll just remove all, and I'll set the working directory here in E drive, and then I'll create that vector. Okay, so this is vector X. This is numeric vector where we have 5 element, 1, 2, NA, 10, and 3. Okay, so if I check the class, right, so this is a numeric, that is a data type is a numeric of this X. So then, for example, I need this 10. I need to extract this 10, and 10 is at which position? 10 is at fourth position. This is first position. This is at second position, then third, and here we have fourth position. So what I have to do for extracting this 10, I just have to specify this name. So name is X. Then I can use big bracket and 4. So it will extract that 10 here, and then I'm storing this 10 inside X1. So let me just run this part. So if I run this part, it will basically give a result as 10, right? And then I'm reassigning this whole thing in X1. So if I run this, here we have X1 where that contains value 10. And you can check the class. This is very important because class of subsetted as well as the original must be same if you are using big bracket for extracting any element. So if I run this, it must have the same class. And you can notice the class of subsetted element, that is X1, is numeric, and class of original, this is again a numeric. Okay, so these two are same. And this is in case of a numeric vector. Same things works in case of character. So here we have a bunch of names. So this is a character vector. Yeah. And suppose I need a first name, third name, fourth name, and fifth name. Right. So I can extract that using this structure. So we'll have to first specify the data frame name. Okay, vector name. So here we just have a vector. That's why we have to use a vector. In case of data frame, we'll have to use a data frame name. So the object name, this is name, then big bracket, and inside that we'll have to specify the indexes, right, for the element that you want to extract. So I need the first element, third element, fourth element, and fifth element. That's why I'm specifying these 4 number. And because we have here more than one number, right, so we'll have to wrap all these number with the combined operator C. I can run this and I can store, and here we have name 1 where we have 4 names. The next is you can very easily check the class. If I run this, I'll give here, and class is a character. Okay, so this is in case of a character objects. Similarly, we can create a logical objects, right? So this log underscore vec, this is a logical vector where we have true and false stored. I can check the class, it must be a logical, and for example I need the first one is true. So what I can do, I can refer this vector name bigger bracket 1. Okay, so if I run this part without the class statement, it basically extract true. Okay, and if you want to check the class, you can run the class statement on top of that, and we'll give here class as logical. Okay, so this is the difference, right? You can very easily check the you can very easily utilize this big bracket, and you can check the data type of subset as well as the original. So in case of a single big bracket, the class must be same of the substitute element and the original element. Same things works in case of complex objects. So I'm creating here a complex object. I can check the class. This must be complex. For example, I want to extract this 1 plus 6 high. This is a third position. So I can specify this vector name, a big bracket 3, and we'll extract that third thing. And if I check the class, here, this is a complex. Okay. So this is the way how this works. So I'll pause here. Any questions so far, anybody? No question?
I have one question.
Yeah, please, sir.
Here name we have created like Fatima RK. So if there is any missing, so in that double quotation we have to keep underscore char underscore, correct?
In the double quotation, you can just use a blank, right? And for example, let me just do that. So if you want to create, if you don't know a name, right, you can use this way, or you can use NA underscore character.
Okay.
NA, sorry. Yeah. So these are 2 ways of storing the character. So if I run this name here, so you can notice this is a blank, right? And this is NA. Yeah. But yeah. So here, if you notice, it is just giving NA. In the case of numeric, it also gives us NA, right? But for checking the data type, you'll have to check the other element, right? Because this is a vector, it must store of element of the same class, right? So the all other element are characters. That's why this also must be a character data type. Yeah. So this is one thing that we'll have to keep in mind, because in the output it'll give NA in the case of character as well as in the numeric. Let me show you that as well. So here, if I print this X, you can notice here is also giving NAs, but the other elements are numeric because we don't have quotations, right? So this is numeric NA, whereas this one is character NAs.
Character.
Yeah, and this is a missing values. Okay, so this is 2 different things.
Yeah. Thank you.
Perfect. Any follow-up questions? Anybody? Okay, so let me just cover the list. So I already covered the creation of list. For creating the list, you just have to use list function, right? And you can specify the objects. here, or so not objects, list elements here. So first element is 1. The second element is basically combination of 3 letters, 1 4 7. Okay, I combined is the combine operator C. That means this all 3 appears in the same compartment, right? Then the third compartment is so just a 5, and in the fourth compartment will store a 4. Okay, so this is the structure. If I run this, it will create like this. So you can notice at the first compartment it's just storing 1 because I specify 1 here, and this is the indicator for the compartment, right? This is a big bracket, double big bracket 1. This is first compartment. In the second compartment, this is 2, and here because I use combine operator, so it will basically store these 3 numbers together here. Okay, 3 4 7. This is second compartment. Then the third compartment is stored just a single number 5. So here we have 5, and at the fourth compartment store a single values of 4. So this is the way how it creates a list. I can print that. I can check the class. This must be a list. Okay. For example, I want to extract the second compartment, right? And I also need second compartment and a second and third element. So for example, I want to extract here. Let me just write. Want to extract 4 and 5 together. Okay, so I just have to write the syntax. So 4 and 5, let me just show you how to write. So 4 and 5, where it is? So this lies at the compartment number 2. Okay, so for extracting anything, we'll have to specify the list name or object name. So because this is list, and here I specify int underscore lst as object name. So int underscore lst. Then I'll have to use 2 big bracket. Why? Because the list, this is a list, and I want to extract this 4 and 5. So first of all, I just have to specify the compartment number, and this 3 4 7, these 3 values store at the compartment number 2. So let's specify here 2. Then I want to extract 4 and 7. This 4 and 7 lies at the compartment number 2, right? 4 is at 3 is at the first position, 4 is at second position, and 7 is at third position. So what I have to do, I have to specify 2, 3, and because we have 2 numbers, I'll have to use a combine operator C, and I can wrap these 2 things together. And if I run this, it will extract a 4 and 7. Okay. Suppose I want to store in another object name, so I can use int underscore lst underscore sub, because this is us basically we are doing subsetting here. Okay, so I can do that, and I can store here, and I can check the class of this subset element. So you can notice the original objects int underscore list is or list, right? So this the class of this whole thing, right? The original objects is list, whereas the class of substitute element is not list. This is numeric. So you can notice we have a difference. So in case of a double break bracket, if you are using double break bracket for extracting anything, where it is a list or a data frame, so you must have a difference in class of substitute element as well as the original element. Okay, so this is the way how this works. So in case of list and data frame, we generally use a double big bracket. Why? Because this is an inherent way of creating the element. Okay, so this is a correct way. For example, I want to extract 3 4 no, as for example, I want to extract this 5. So 5 is at compartment number 3, so I can specify this object name, then double big bracket and 3, right? This is a correct way of extracting a particular element that is stored at the compartment number, right? Sometimes people like single big bracket. This is not a correct way. Why? Because it will extract that whole thing, but it also preserve this list structure. So if you notice in the earlier one where I'm using double big bracket 3, so it is extracting just a number. Whereas if I use a single big bracket 3, so it will extract that 5, Along with this 5, it also preserves this matrix notation, list notations or a compartment notation. So this is not a correct way. And if you check the class also, this must have a numeric class, whereas the second one must have a list class. Okay, so you can notice this is the difference. Yeah, so that's why we generally use a double bracket for extracting an element if that original element is of a list kind. Similarly, I showed here a bunch of other examples, so I'll just go through this one by one. So here I am creating here a list again, right? But there is a difference. I am specifying also the name. Okay, so if you compare with the original one, here I just specify the number. I have not specified A is equal to B is equal to, right? I just specify the values, whereas here I'm specifying values along with the name. So let me just run this. If I run this here, so this creates, okay, the difference here is instead of this big bracket and number inside, right? If I let me just run this original one, yeah, int underscore list here, so that we can very easily see int underscore list. If you notice the difference, in the first one I have not used the names, right? That's why we have here a double bracket, a big bracket 1, double big bracket 2, double big bracket 3, double big bracket 4. But here in our, when I am creating the list here at the line number 61, I specify A is equal to B is equal to, so I gave here a name, right, for a specific compartment. That's why instead of this double bracket, a big bracket 1, I have here dollar symbol A, dollar symbol B, dollar symbol C, and dollar symbol D. So if we have a name, you can use these name for extracting the elements. Okay, and that is an efficient way. Okay, I'll show you that comparison later. So for example, I want to extract this compartment B, compartment C. So I can very easily do that. I can just use a combine operator and I can run these two things together and will extract. Okay, you can notice, and the compartment B, we were having 3 number 3, 4, 7, and at compartment number C we have just single number 5, and I am using here a combine operator. That's why I just will combine all all 4 number together. Okay, so if I run this class of this LST, it must be a list class. If I check this one, this must be of numeric. So here also there must be a difference if you are using a dollar symbol, right, for extracting the element. Similarly, we can extract this third one, the compartment 3, where we just have a single number 5. So I can run this, I can extract, yeah, and I can run the class as well. This must be a numeric class. Okay, any question? Hi Bhavna, thanks for joining.
Hello, sir. Thank you.
Hello. Yeah.
I have one question.
Please.
That list you have created, that is first example. Can you please go up?
Yeah.
So there we have given different compartments. This one.
Yeah.
So if you want to what we call extract the data from different compartment, then what we have to do here? Because in the down we have mentioned A is equal to B like that, but here it is not there like that, A and B.
Yeah, so here
So how can we
you just have to use a double big bracket for extracting. For example, I need int lst. For example, I want to extract the element, right, from this compartment number 2. This is compartment number 2. This is compartment number 1. Yeah, so I can use here compartment number 2. Okay, it will extract. Oh, sorry. Okay. Okay, I don't know. Give me a second. Oh, ind underscore list, and then oh, I don't know why this is not okay. This is, I guess this. Oh, sorry. I use here. If you notice, I use here capital letter I. Yeah, I must have to use the same nomenclature. Small ind lst, and will extract. For example, I also need this compartment number 3. Okay, so what I can do, I can just write here comma ind lst big bracket 3, and I can combine these two things together using the combine operator C. Yeah, so this is the way. Hope this makes sense.
Yeah.
Okay.
Yes. Thank you.
Perfect. No worries. Similarly, how we can extract the element from a data frame. Okay, for that, I'll create here a data frame using data frame nomenclature. Right here we have names, age, gender. Right. Let me run this. This is the class. This is data frame. For example, I want to extract this age. So how we can do? If I write this age, right, it will not show. It will give an error message. Right, object is not found. Why? Because age is there inside this data frame, so we cannot extract this way. How we can extract? We'll have to write here. So we'll have to write data frame name, dollar symbol, variable underscore name, or column underscore name. Yeah, so this is the nomenclature we'll have to follow. This is a generic formula. So how we have to do? I just separate data frame name. This is df dollar symbol. I will give auto suggestions. For example, I need the column of age, so I can just write extract these values. And if you notice, these are the same values as of this age variable: 34, 33, 35, 36, and 34. Similarly, if I want to extract this gender, I can just write this df dollar symbol gender, and here we have. Okay, for example, if I want to check the class of this age, right, I can pass this whole thing inside the class statement. I'll give here the class. So if you notice, the class of this original object's df is data frame, right, whereas the class of this subset element age, this is numeric. So this is the difference. Okay, so this is the way how this works. Okay, so I'll pause here once again. Let me know if you have any question on this data frame.
If we want to subset that age and gender together, then we have to do
yeah,
what we
so
have to do.
age and gender together. So one thing you'll have to keep in mind, the data type of age is numeric, data type of gender is a character. Yeah. So you first have to convert and make as a same data type. Okay, for example, I can do that. So this is the way of extracting the age, and then what I can do, I can run as dot character function. Sorry, ARACT here. So what this does, it will convert these numeric values into a character data type. If you notice, now these are in quotations, and then I can combine with the other objects, that objects of gender, and I can wrap this whole thing inside the combine operator C. And here we have. Okay. Yeah. So this is the thing. If I don't use, right, if I just remove that, for example, so this is a more appropriate way. This is the way I'll recommend, right? This is correct way or recommended of combining different different objects slash variable together. But there is another shortcut, but I'll not recommend that, but that also works. I can use a df $age and I'll combine df $gender. So here if you notice, I'm committing one error. Why? Because this is a numeric data type and this is a character data type. So if we combine these two things together, what this does, it will basically do an internal coercion and will try to accommodate the data in such a way that there should not be any loss of information. That means it will convert this number into a character data type and store there. But it also shows, yeah, you can notice this is the way. You can notice it directly converted this age into a character data type and it will store with the gender. Why this is the way? Because we cannot convert this alphabets into a numeric, right? So there is only one route, and that is just convert this number into a character. So this is a default or built-in structure in R, right? So just to accommodate the data in a better way without losing any kinds of information. Hope this makes sense.
Yes.
Yeah.
Thank you.
So here, this is an example of internal coercion. Okay, or implicit coercion. This is again another name. Implicit coercion means what? Coercion is what? So coercion is just converting a data, right, into another data type. Okay, so internal means this is a default functionality of R. It do as its own, right? Implicit coercion, this is example. Explicit coercion is what? Explicit coercion is when we are using some explicit function, for example, as.character, as.numeric, as.logical, as.complex, for converting one object, right, to another using some explicit function. But internal coercion just occurs as a default built-in functionality of R. Okay, so any questions, anybody?
Yeah, I have one question.
Please.
Yeah, can we go up?
Yeah.
Suppose if we have to, can we use the condition statement in this
Yeah,
data frame?
I'll cover that condition.
Of $gender. Yeah,
I'll cover that condition
if
statement later.
I want. Okay.
Yeah.
Oh.
So because I don't want to overwhelm and mix up all the concept together, so we have a dedicated class for conditional statement. Okay.
Okay. Yeah.
Okay. So any follow-up question on this for extracting the things? Okay. So now I'll showcase some mathematical operators, for example, subtraction, multiplication, additions, division, remainder calculations, then quotient calculation, then power. These are the symbols. These are very famous and originally used in most of the programming languages, right? So I'll use here a numeric vector, num1 and num2, and I'll do all all sorts of mathematical operation. I'll showcase these one by one. So first is here the addition. So I can specify the order, because in the addition the order does not matter. And how this works, it will basically do element wise operations. So it will do element wise addition, it will do element wise multiplication, and so on. So all mathematical operation it performs on an element wise basis. So for example, if I just run this num2 plus num1, what this does, it will add these 2 plus 2, 4, 4 plus 4 as 8, and 5 plus 3, 8. Okay, so it is basically doing a element wise addition, and this is a result 4, 8, 8. If I run this, right, so here I'm just adding these two things and I'm storing here in another vector named add, right? Similarly, we can print, for example, I can do the, so now I'll not create the variables here because I don't want to create a whole lot of variable. I'll show you that part later, but here I'll just do the operations and I'll use a print statement for printing those results. So we can add that, right? We can subtract num2 minus num1. So 2 minus 2, 0, 4 minus 4 0, 3 minus 5, that is minus 2. And here we have. Similarly, we can multiply. So 2 into 2 4, 4 into 4 16, 5 into 3, that is 15, and this is the result. Similarly, we have division, remainder calculation, quotient calculation, and power calculation. Power calculation is same, right? So here I'm using num1 to the power num2. So 2 raised to the power, sorry, this 2 raised to the power 2, that is 4. Then 4 raised to the power 4, that is 256. And then 5 raised to the power 3, that is 125. Okay. Similarly, the remainder, this is again same. So in case of remainder, so 2 divided by 2, so we'll not have any additional thing, right? So this is completely divisible. 4 4 divided by 4, this is again with no remainder. Okay, this is completely divisible. Then 3 divided by 5, so we'll have here remainder as 2. So yeah, 1 divided by 2. Yeah, so 5 divided by 3, right? So we have here a remainder as 2. And in the case of quotients, because in all 3 scenario we have a quotient as 1. Okay, so this is the way how this works. This is very simple. This, what we have to remember, it do all mathematical operations in element wise basis. Okay, element wise addition, element wise subtraction, and so on. Okay, so any question on this? Anybody? Okay.
I
Yeah,
have
please.
one question.
Sure, please.
Here, element wise, it is adding or it is doing mathematical operation. If there is any NA, means missing value, so it will be the same.
Yeah. Very good question. So I'll come to that point here. So I have that example. Okay. So let me just cover one thing. So for example, here, if you notice num1 and num2, here we have an equal number of element in the vector. Yeah. But what about if we don't have equal number of element? For example, I'll just remove that from here. So if you notice in num1, we have how many elements? We have total 5 elements, 2, 4, 5, 6, 5. Okay, so this is our num1. Let me print this num1. In num2, we have 3 and 2. So what if I add these two things together? So here it'll try to accommodate, right? It'll try to replicate this, the vector that have a smaller number of element, right? In such a way that it'll replicate, right? In the same, it will replicate in such a way so that it'll have same number of element as of the other one. Okay, so because we are adding num1 and num2, so we'll try to replicate these number 3, 2, right, of this num2 vector in such a way that it'll also have total as 5. So how it replicates? So we have here 3, 2, then we'll have 3 again, then we'll have here 2. Okay, so now we have total 4. So we must have one more. Okay, so it will replicate these 3 again. So now we have total 5, and then it'll try to add this with num1, and in that case the same element wise additions occurs, and in that case 3 plus 2 5, 4 plus 2 6, 5 plus 3 8, 6 plus 2 8, and 5 plus 3 8. Okay, so let me just showcase this result. Okay, but it also gives a warning. Why? Because we don't have an equal number of elements. So you can notice it is giving here warning. Longer objects is not a multiple of a shorter one, but it'll do the replication of the shorter one, right? And it will try to replicate in such a way so that it must have the same number of element as of the first first objects, right? So you can notice, and here we are giving the same answer. We are getting the same answer. So we'll try to replicate in this way. Okay, if we would have here 6 elements, so we'll try to also replicate. It will try to add here 2. So let me do that. So here I can add one more. So now we have total 6 element in num1, and in num2 we just have 2. So it replicates right 4 more times. And if I print this add, so here this is the result. Okay, so because it also already gave a warning here, so that's why it will not give warning again. So this is the main part. Okay, and it'll give warnings in case of mismatch. For example, if we have a multiple, if the second element is multiple of the first one, so in that case the replications occur in a symmetric way, right? So because it replicates all the element equal number of time. In case of odd, right, so it replicates one number more than as compared to the other number. So that's why it'll give a warning of this kind. So the longer objects is not a multiple of the shorter one. But in case of the even number of, right, so in case of even number of numbers, so if the second or a shorter one is just a multiple of the longer one, right, so shorter element is a multiple of the longer element, so in that case it'll just suppress that warning. Okay, because over there we'll have a complete replications. Okay, the next part is the same thing that Swati just asked, right? So here I'm creating a num, right? This is a numeric vector where we have NAs at this third positions. So we have total 5 number, 1 for NA, 4 number, 1 for NA and 6. So if I do the sum, so it'll not give NAs. So how we have to resolve? You'll have to use here NA is equal to true. Okay. So it will just add the non-missing values. Similarly, it works in the same way in case of median and mean. Okay, it'll evaluate. So here I just have to use na.rm is equal to true. So what about if I add 2 vectors and one vector has na? So let me just create here num1, 1, 3 and na. Then num2, C, 2, 3, 5. Okay, so we have NAs this third element in first, and we don't have NAs here, we just have 5. Okay, so let me run these two, and now I can add num1 plus num2. So as default, it'll not provide any values for this last one because it will add this 5, and NA plus 5 is NA. Right, so it will return a result like this. So how to resolve? So first of all, the main and obvious answer is just to fill that NA. If that is not possible, so we'll have to use some function here. So I can use sum, I can use num1 comma num2, and I can use na.rm is equal to true. So this is again, this is not element by sum. It will basically add these two things together, right, after after removing that na. Okay, so you can notice it is just adding all things together and just dropping that na. So 1 plus 2 3, 3 plus 3 6, and then 6 9, and 9 plus 5, that is 14. Okay, so this is a grand total. It is evaluating, not the element wise summations. So in case of this na, so there is no other way. It will basically represent na. So there is one and only one way. You can just suppress that part. Okay, you can suppress that element right altogether, or the other thing is imputations. I'll show you the imputation as we proceed. So imputation is a way of filling NAs with some appropriate values. What are the appropriate values? For example, here what we can do, we can evaluate the mean of rest of the non-missing values, and we can replace that NA with that, right? We can also evaluate the median of rest of the non-missing values, and we can replace that NA right with that median. Sometimes we'll have to do very sophisticated mathematical operations. We can use multiple imputation, where we simulate a very large number of data, right, using some model, and we'll try to impute with that model, right? So I'll not cover that modeling part, but I'll show you how to do a single imputation, where I'll show you how to fill that NA with some appropriate values. It can be mean, it can be median, it can be other summary statistics, or sometimes we'll have to fill those NA with some arbitrary values. But in the case of arbitrary value, we must have some rationale why we are adding, why we are filling those NA with some arbitrary values like 14, 10, or whatever. Okay, so these are the things that we'll have to keep in mind. Hope this makes sense.
Yes, thank you.
Okay, thank you. Okay, any follow-up question, anybody on this? Bhavna, Harish, hope you're following.
Yeah, no problem. Yeah.
Okay, thank you. Okay, the next
Yes,
part
no
is,
question.
okay, thank you, Bhavna. Yeah. So next part is here I just showed with the individual vector, right? But in most of the time in the real programming, we must have a data frame. Okay, so what I'll do, I'll just import a data frame from my external drive, and I'll show you how to do the operations, how to add, subtract, multiply, right? Because in the real programming, we must have to face with the data frame. That is not difficult. This is very simple. So here I have a data. Let me just show that data. We have here data 1 and data 2. Okay, this is again a text file where we just have two variables. One is num1 and num2. I'll show you how to perform mathematical operation, right, that I showed so far. Okay, so first of all, this is text file, so I'll have to import that file, and then I can perform a mathematical operation. So this text file is located right at this location. I already set my working directory. Okay, so I can specify just a file name with the extension txt, and this is a text file. That's why I'll have to use your read.table function. And because that file contains header, so that's why I'm using header is equal to true, so that I'll not create any header for us. Okay, so let me run this. It will create the objects, right, and store here in data1. Okay, so here I can show you this data1. This is again the same thing, num1 and num2, where these are two columns or a variable, and here we have 5 values. Okay, so next part is suppose suppose this file is located at some other location other than this working directory, so I can specify this explicitly, right? So I can specify the path, and I can very easily import. So you can try this. This is another way of importing if your file is located at some other location other than your working directory. Okay, the next part is I'll show you the data. So there is again another function. You can double click, you can just click here right on the data set, and it will basically open here in the editor. This is a view, or you can use explicit view function where you'll have to use capital V, right, and you can open that data set here in the editor. Okay, you can check the class. This must be a data frame. Okay, you can check the structure where we just have here two variable and both are integer type, so we can very easily perform the mathematical operations. So how to perform? So first of all, you'll have to recall how we basically call a variable from a data frame. So here in this data frame data1, we have two variables, num1 and num2. So I cannot write num1, right, for extracting that. I cannot use this. I'll have to specify first the data frame name, data1, dollar symbol, num1. So it will extract that column for us. So you can notice we have here 1, 12, 30, 4, and 5. Okay. Similarly, we can extract num2, data1, dollar symbol, num2. Yeah, 19, 12, 17, 20, 17. Yeah, so these are the two variables. So for example, I want to perform a mathematical operation. What I can do, I can add here a plus symbol, and I can place this second variable here. So this is the way how we can perform a addition in case of a data frame. So the difference is, in case of numeric vector, right? We generally directly have to use ref for the numeric vector, and we have to add the mathematical operation in between. But in case of a data frame, because the calling is slightly different, so we'll have to use here a dollar symbol for calling that variable. Okay, so this is an additional step that we have to perform, and we can add these two things together. So if I run this, it will basically add, for example, I want to store, so I can specify name, right? And we'll store with the vector add. So we'll create a here add as a vector 20, 24, 47, 24, 22. Okay. Then you can create add one also, right? So you can create a number of variables. There is no problem. And this R is case sensitive, so you can also create with this capital add, right? So that is also appropriate. Okay, so this is the way. I'll not create here a data frame. I'll just perform all the mathematical operation one by one. And this works in the same fashion, right? You can verify very easily, right? So this is the same. The remaining part is, for example, I want to create I want to add this, right? And I want to create a new variable, right, in this data frame data1. So right now in this data1, we just have two columns. One is num1, the other is num2. So I want to add these two, and I'll create here a new column of additions. So let me show you how we can create that. So the operation is same. We can perform this operation, and then here I'll have to first specify the data frame name, dollar symbol, and then variable name. So what this does, it will create a new column, right, with name add in this data frame data1, where it'll add these two vectors together. So here, this is the thing. So right now, if you notice in data1, we have three variables, num1, num2, and add. Okay, so this is the structure. Similarly, we can do the subtraction. We can do this subtraction here, num2 minus num1, and I can store here in sub. Then we can also perform multiplication, and you can store with mult, division, remainder, quotient, power. Okay, so if I open this data1, we have here total 9 variables, and here we have a result. We can verify very easily. For example, in the case of multiplication, so 90 into 1, 90, 12 into 12, that is 144. Then here 4 into 20, that is 80. Then 70 into 5, that is 85. So you can verify the other calculations in this in the same way. Okay, so I'll pause here. Any question? Anybody? No question? Okay, so let me show you a real example where we'll use these applications. Okay, so let me just revert my laptop and I'll show you here. Okay. Okay, hope you can see my screen. Can anyone confirm this whiteboard?
Yes,
okay, thank you.
yes.
Okay, perfect. So here I am giving here an example of this mathematical evaluation. There are multiple examples. There can be multiple examples. So one of the example is in the case of this diabetes study, right? So if we have a chance of working with the diabetes, there is one parameter that is very important, and that is called HbA1c, right? So for example, a company A is trying to introduce a medicine for hypoglycemic patient. So for example, you can think of company A. This is trying to introduce a medicine for diabetes patients, right? And here the the parameter should be, right, HbA1c. This is the parameter we generally use as a primary endpoint or primary parameter. Okay, so we generally use this HbA1c as a primary, and then other parameter, for example ppg, FVG, right, these are we generally use as a secondary endpoint, right. So our goal is, in case of hypoglycemic patients, right, so the goal is just to reduce the concentration or the values of HbA1c. Okay, so this should be the goal, right. This will be the goal, right. It eventually reduces the value of HbA1c, right, if the drug is efficient. Okay, so this should be the goal. So here there are two things we generally do. So for example, at the baseline, so maybe you can think of this is a schedule here. At this point we are giving the treatment, so let me just write this way. You can think of this is a study duration, right, and here in the middle, right, maybe not middle, at the beginning, for example here, this is a time where we give the medications to the patients, right. So this is a treatment administration. Okay, so what we do, we try to measure the HbA1c values, right, before giving the medications. For example, this is our maybe screening visit or baseline visit. So at the very initial stage, right, so this is called baseline. So here we'll measure the values, we'll record the value. Okay, and why we generally record the values at the baseline? Because this provides the status quo or as a reference values, right. So this will provide idea about the reference. Or a reference. Okay, so here at the baseline, because we haven't given the medication to the patients, there should not be any influence of the treatment, right, at the record of this baseline, right. So here there should not be medication on the values of. Okay, hope this makes sense. Is this clear?
Yes, yes,
Yeah,
Sanjay.
perfect. So after giving the medications, we try to record the HbA1c. There might be multiple instances, right. So these are called a post-baseline assessments. Why? Because these are recorded after the baseline, right? Then our sole purpose is just to compare the post-baseline values. And here we are recording these values after medications. So there should be influence of medication. Okay, so we should have an influence of treatment, right, or medication on these values, because these are recorded after giving the medication. So because if you take the medications, it should stay for a couple of durations, right? It will stay in the body for a couple of duration. I'll try to target the disease conditions, right? So that's why it will influence. So if your drug is, if the drug, right, that the pharma company is targeting, right, if the drug is efficacious, just try to lower the value of HbA1c, right? Because in the case of hypoglycemic patients, our goal or sole purpose is just to reduce those values, right? So it will influence. So here, what we want to estimate, we try to estimate sometimes difference. So post baseline minus baseline, this is called change from baseline. Okay, so let me just shift this. Okay, so we'll evaluate here a change from baseline. So first thing is, we'll evaluate what a change from baseline. Okay, this should be post baseline values minus baseline. Then the other thing is, sometimes we also evaluate absolute change from baseline. Why? Because sometimes maybe the team is interested only on the magnitude, not on the sign. Because in the case of change from baseline, here we may get here we may come up with the negative values. So we can have a negative as well as a positive values, right? So if we do any kinds of summations or means, so positive and negative values cancel each other and not get meaningful answer. So that's why we evaluate the absolute values. And in that case, what we do, we use ABS functions and we try to remove the negative sign. Okay, so if you use ABS on a negative A, so it will give A, and in that case we'll get magnitude, right? So here we only get magnitude. Okay, then the third one is percentage change from baseline. So how we have to do it? Same thing, post baseline minus baseline divided by baseline. And then here we'll have to multiply this whole quantity by 100. Okay, this will be our percentage. Then there is one more quantity that is called ratio to baseline. So as name suggests, so for example, I have to evaluate the post baseline, for example, visit to ratio to visit to. So what we can do here, we can evaluate the post baseline values. So here, post baseline values minus baseline values. And these are basically appropriate in case of a ratio scale, right? This is in case of maybe normal scale. This is again a normal scale. This is again normal scale, but this has a different interpretation because we are showing the same quantity in terms of ratios. Okay, so this is appropriate in case of a ratio scale. So hope this makes sense. Any questions so far, anybody on this? Because this is very important, and this is very simple because we as a programmer we need to do this calculation on a very regular basis. Okay, so any follow-up question on this?
No question from my
Yeah,
end.
so if you want to take maybe a screenshot, because I want to be able to share this,
Yes.
right? So maybe you can take.
Yes, I have taken.
Okay.
Yeah.
Yeah.
Okay. Yeah.
Yeah, maybe Bhavana and Harish, you can also take this as a screenshot.
Yes, sir. Yes, sir.
Okay, thank you.
Yeah.
Okay, perfect. So the next part is how to do the programming for this. Right. So I already wrote here the description. Right. So sometimes we may have, so one thing, sometimes we may have multiple post baseline assessment, right? So in that case, the team basically provide one baseline as an important one, and we try to use that values, right, as a single post baseline assessment, right, or single post baseline values, and we try to compare that value with the baseline. Okay, in case of multiple, if you, we try to incorporate multiple values, so in that case we can apply maybe modeling. For example, we can apply mixed model, we can apply ANOVA, we can also use ANCOVA, and we try to compare these values, right, with the change. Okay, so I'll not cover that part here. I'll just show you with the single values. Okay, if you have interest, maybe just let me know. I'll try to cover if time permits. Okay, so I'll create here, I have a data set, data2. I'll try to import and I'll show you. So here we have two variable, baseline and post baseline, and here we have bunch of values. So this is the same calculation, right, as of above, right? So maybe you can think of this num1 and num2. Num1 is maybe a baseline values, num2 is a post baseline values, and you can perform all calculations in the same fashion. Okay, so first is change from baseline calculation. This is a very simple, values of a post baseline minus values of baseline, and this is the same thing, and here we are creating a new column of a change from baseline, and here we have. So let me just show you this data. So here we have, so we are using post baseline minus baseline. That means 9 minus 1 8, 12 minus 20, that is minus 8, right? 17 minus 31 minus 14. So you can notice some positive values and some negative values. So this is the problem with this change from baseline calculations, because we'll get some positive values and some negative values. And if we use average, so sometimes positive values and negative values try to cancel each other and not get a meaningful answer. Okay, so that's why the absolute change from baseline may provide some meaningful answer. Okay, so let me show you how to do that absolute change from baseline calculation. So first of all, I'll show you the example of ABS function, and this will do the absolute calculations. So let me run the C. This is a C where we have here four values, 1, 2, minus 4, and minus 5. And for example, I want to evaluate the absolute. So what I can do, I can use ABS and I can pass this C. So what this does, it will convert these negative values into a positive one. Okay, 1, 2, 4, 5, and here we have, right? Similarly, this is the change from baseline calculation. If you want to do the absolute change from baseline calculation, what I can do, I can run the absolute function on top of that, and here I did the same thing. Yeah, so you can notice I call this variable separately, and then I run a ABS function on top of that. Okay, so we can perform and we can store with the new variable ABS change from baseline. Or you can just refer this variable change from baseline, because I already evaluated the change from baseline here. So I can refer that variable, right? And I'll use ABS function on top of that. These two evaluations yield the same answer, right? So you can notice this column, the last two column, right, yields the same values. Okay, because both here we are just evaluating the absolute change from baseline. Okay, the next is here a percentage change from baseline. This is a same thing, you'll have to convert that in terms of percentage. So first, this is change from baseline calculation, and then I can divide that whole thing by baseline values, and then I'll multiply by 100, and this is nothing but the percentage change from baseline calculation. Yeah, and here we have. Then I can check the column. So right now we have multiple columns right here. I can use as per our requirement. Okay, so these two are very important function, call and names. It'll give the same thing, the column names, right, of a particular data frame. Okay, so this completes the session here. Again, I just want to emphasize, so these are the two packages yesterday I showed, right, where we have built in string datasets, so you can utilize this package. And there another package formatters are right here. We have built in RM datasets, so you can utilize this data for the practice purposes, right? And that's all. So this completes the session, and let me know if you have any question.
I have one question.
Please.
We have calculated that absolute percentage baseline change, correct? So there we have many values after decimal in the data set.
Yeah.
So can we handle that decimal values also?
Yeah, we can handle very easily. There is no issue. What you can do, you can just run a round function on top of that. Yeah, I'll have to use parentheses, and here I can wrap maybe 2, 3, whatever, and it will just handle that very easily. You notice this is wrapped. You can use exactly. If you want to convert that into character data, yeah, you can just run as.character function on top of that. So we can perform, because anyhow I'll cover these evaluations, right, as we cover the part 2 of the course. Yeah. This is now incorrect.
I have one question actually.
Please.
It is not related to this calculation.
No, it's okay.
So we have to write this code in a single line, or we can split the code also.
Yeah, you can split, but you should have a proper splitting thing, right? For example, I can split here. I can send this whole thing to the next line. This works. There is no issue. For example, I can run with Control R and reevaluate. But you cannot, for example, I cannot split from here. Okay, I cannot split like this. Yeah. Sometimes this works, but this is not a correct way. So when I cover dplyr, I'll show you. So whenever you use comma, for example, this one here, if you notice, I specify the dataset name, right, that I want to import, and then I have comma. So you can specify, I can send this whole thing to the next one. This is appropriate. This is recommended. So I'll take one class, right, at later session in the part 1 of the course, where I'll show you how to write a code right in a better way. So I'll cover one class where I'll describe the good programming practices, right? So where I'll show you how to specify the variable, how to use indentations, where you'll have to break the code. Okay, so I'll cover that in that session. Okay. Perfect. Yeah, anybody, any questions? Pauna, Harish?
No questions, sir.
Okay, so
no questions.
Any thoughts so far? Because right now we are I'm completing this in 9th class, right? So any suggestions, any place where you feel that you are not getting things properly, where I can put more emphasis or more example? Any thoughts how you're feeling this R, right, as compared to the other programming right, other programming language that you know? Is it simple or tough? Any thoughts?
As compared to SAS, I think for me it is a little tough. I am feeling.
Okay. No worries. So maybe
I think I need to do the practice. I didn't start the practice yet.
Exactly.
That's the reason.
Yeah. Harish,
I'm feeling.
Okay.
Yeah, how you are teaching and explaining. Yeah, it's good.
Okay. Thank you, Swati. Yeah, Harish, Bana, any thoughts?
For me, it's interesting. Yeah, it has lots of package, right? Exactly. We have to remember lots of package. Yeah.
Bana, anything?
Yeah, sir, I'm still in this SAS coding and all.
Okay.
I'm getting used to it. I'm just processing all these
Okay.
things
Now,
because I'm from non-background
no, it's okay.
programming background. So
It's
I'm
okay.
just
It's okay.
processing.
It's okay. It's okay. Yeah, no worries. So just take your time and don't hesitate if you have questions. Yeah, just let me know. You can ping me on a WhatsApp group, right? So I'm here just to support. Okay, so just keep in mind and don't hesitate because we all are learning, right? So that is a main part. Okay, so that's all for the day. Any last minute questions, thoughts, anything?
Yeah, I have lots of questions actually.
Yeah, please.
Actually, here in the that editor window,
Okay.
you can see that untitled 1, 2, and one star symbol is also there.
Yeah.
So, what is this actually?
So these are not saved file because I took multiple classes, right? So that's why I generally don't save codes, right? Because I took the class. Sometimes I have to add some ad hoc thing, right? While explaining some parts. So that's why I generally don't save. If I save, so what I can do, I can go here. I can use save as or save. So in that you'll not find that name. For example, I'll just write here class 09. So in that case, you'll have a proper name without this untitled. Okay, hope this makes sense.
Okay, so we can save like this our program.
Exactly.
Correct?
Yeah, exactly.
Save
Yeah.
as. Okay.
I generally don't use this
And
way.
that file extension.
Yeah, I generally don't use that way. I'll just use this Control A. I can copy all the stuff because I have to provide all the codes in the Word document, right? So I'll just go here. This is my folder. I'll create a new Word document. Okay, and I'll paste here, and then I'll convert that whole thing into a PDF file form. So this is the way, because I have to provide all the code in PDF format. So this is my way, but you can use this save functions, and you can save it, and this will create our file. Okay.
Okay.
Yeah.
Thank you.
Okay. Any follow-up question? Anybody?
Actually, I have one question. So, how many parts are there in part 1? How many classes required for part 1 and part 2? I missed that class. So.
No, it's okay. So this is the thing. Right now, we are here. I'm covering right now this class number 9. So we finish this. Then we have here class 10 where I'll cover the deployer, then time and date evaluation, control structure, looping function, regular expression. So we have total 22 classes in part 1. Right, so there are 13 remaining classes where I'll take 3 classes on the data visualization. Okay, then I'll cover one day here R packages, R2 RTF package. This is for creating RTF files. Then I'll show you her merging of a data frame. Okay, then here profiling of R code, coding standards, and others, right? So there are 13 remaining classes that is under part 1, and in part 2 we have total, I guess, here also 22 classes.
Okay.
Yeah. So these are the things.
So are we covering R Shiny as well? Or,
no. Here we are not covering R Shiny. I'll give you an example of that. Right. So there is a package safety graphics. Right. I'll cover here in in class number 43. Where I'll give you some claims. This is R Shiny, right, created for explicit for exploring the safety aspects of the clinical trial, right? For example, it can create very easily the adverse event table, patient profile, laboratory tables, and other data visualization tool that is applicable for safety data like EDIS plot, right? Plots for different parameters together. For example, bilirubin on the x-axis and maybe total bilirubin on the y-axis. You can very easily see the pattern, right, or a scatter diagram. So these kind of analysis we can very easily do. So I'll give you application perspective, right, of R Shiny, but this course does not contain the usual model of R Shiny, because R Shiny is altogether a very big topic, right? It requires maybe 40 to 50 classes, right? Because there are a whole lot of things that we need to cover. So we are planning to launch R Shiny, right? So I'm still in creating slide deck of those, right? But because because I generally don't get much time right nowadays, because there are other priorities. But maybe in coming future, maybe in upcoming months, we'll try to announce a dedicated batch for our show.
Okay.
Yeah. Okay. So if you don't have any question, maybe we can solve the class and we'll meet tomorrow, and I'll show you some other functionality of R. Okay. So thank you everyone. Thank you for your time. Bye. Have a nice day.